application layer protocol. Okay. Now, there are some key components within HTTP that we all must understand. First is HTTP request, HTTP response. Now, if you look at the middle stack, right, it is showing you a sample HTTP request. Now, what does a HTTP request is? So basically, if I make it even simpler, right, whenever your browser you hit a page, right, what happens is the browser prepares a HTTP request and sends it to the service, and the service will give you back a HTTP response. Now, how does browser understands that what is my response and all, right? So that is through this HTTP protocol. If you look at HTTP request, the first line that you see here, this is called as HTTP request header. Okay. The first one is the operation. So there are multiple operations within HTTP. There is get, there is post. These two are very famous, right? So get is like a query operation. If you want to fetch some page, it is get. If you want to send some data to the service, right, it is post. So let's say you submit a form, something like a user ID and password, and if you do a submit, then it is a post request. Okay. Or any registration form that you fill up, those are all post requests. So that is about HTTP operation. The next one is the URI, the slash that you see, that is the URI. Sometimes it could be slash, it could be slash index.html, or it can be something like slash railway slash book ticket or something like that. The next one is the version of HTTP, HTTP slash 1.1. That is the most in use version, but you could also see HTTP 5 being in use. Okay. Next two lines that you see, those are HTTP headers. Now, what are headers? Headers is something like a metadata that tells the server about the request, like what was the language, what does the request data is of type, is it text, is it JSON, is it a JavaScript file, is it a CSS file, is it compressed? So all that information is passed through the HTTP headers. Now here you see two headers, host, which tells you what is the host is being called. The next one is accept language, that is to specify which language is being requested. If you look at the left side, there are some more headers. For example, what is the encoding? So it is saying ggip. So it means it is compressed. Then there is a user agent. User agent tells you what kind of client is used. So it says Mozilla. So it's telling that it is using a Firefox browser. For Chrome, it would be different. If it is a program, it would be different, something like a Apache HTTP client and all, right? Okay.
Yeah,
The
Bluetooth connected ना बाकीचे तर outlet आहे.
okay. Uh, So that was about the headers. Now the next important part is the request body. Request body is the one wherein your whatever data that you pass, right, that gets passed. So if you look at the left side, you selected a book in your page, some author and all, right? So that gets passed in the request body. If you look at the left side, book ID equal to 1234, author equal to 10, right? So that is so this is HTTP request. And if you look at HTTP response, this is what the service provider sends to the server. So this is what the server Okay, I'll show you on browser how it looks, right? So if I open some damn page, right? So I'll hit, let's say Google, right? If I hit this, if you look at, I'm sorry, where is it? Yeah, if you look at the dev tools and let's go to network. Yeah, if you look at this is a request. So your browser hit this request. Okay, so this is the request URL. This is the request method. This is your response status 200. And then there are some more headers. What was the remote address and all, right? There are some more response headers. Then these are the request headers. And if you look at response, what it has given you? It has given you a JSON, basically a JavaScript code. So similarly, if I look at something else, Gen 2000, so this is also JavaScript. So there would be some request that would have given the browser a HTML, right? So this is how it behaves. Now, before I go to further topics, right, in this, you must be clear now that what is a HTTP, what is HTTP request, what is HTTP response, what are HTTP operations, and what is HTTP response code. If not, please ask questions. I'll again explain. All right, I'll take that as that everyone has understood it. All right. Now that we know what is an HTTP, okay, let us also talk about the history of APIs. So, REST has been popular for almost like I would say 10 to 15 years now. And before that, the most famous one was SOAP. But if you look at the overall history in last 30, 40 years, right, it all started with RPCs. That was remote procedure call. I mean, RPC was not HTTP based. Then came XML based RPCs. Then came RMI, that is remote method invocation. If you have heard of Java EJBs, right? They use RMIs, EJB. That was really popular. But till RMI, right? Although the APIs did exist, but there was always a technology constraint. For example, if you use EJBs, right? You are tied to Java. Now, if you have to use some other programming language, you cannot use it. So if your server is using some language, you as a client will also have to use the same language, right? So to do away with that, right, people started using web services. Guys, just give me a session. There is a noise around. I'll be back. Yeah. So, yeah, as I explained, till RMI, it was always your communication was always language dependent. Now, people thought that in order to make it technology agnostic, right, what can we do? So, people came up with the idea that we can use web services. What does web services means? That you can use APIs over HTTP because HTTP is a generic protocol, right? All languages can implement it. And even if your service is written in some language A, your client need not use the same language and they can use a different language, right? Now, the first thing with web services came was SOAP, Simple Object Access Protocol. Okay, I'll give you easy demo to understand how web services on SOAP used to work. Now, if you look at the right hand side XML, right, this is a sample SOAP message. Okay, No need to worry. I mean, it has a lot of metadata specific elements, but if you look at it, right, it at a high level, right, there are two parts to the message. One is a header, one is a body. Now, in body, your actual object or your actual request goes. Now, I'll show you one demo. Okay, so I found one. Simple online service that is running. So what I'm going to do is, so this is a SOAP service running online for, I mean, and I can use it for training purposes. So I'll copy this, and there is a tool called as SOAP UI, which can be used to generate clients. Okay. So what I'm going to do is I'll create a SOAP project. Now you must be wondering what is a WSDL, right? So what happens is, right, when you have a web service, as we already discussed, right, API is a set of rules or a protocol. Now, when two parties want to communicate, right, there must be set of rules. Now, what is WSDL? We also call it as WSDL. It's a set of protocol when we use SOAP. Okay. Now, if you look at the SOAP document, right, let me go to the operation part. If you see, it is giving you calculator service. You can do add, you can do subtract, you can do multiply, you can do divide. Meaning, if you want to do add, I want an in message add soap in. Okay. And what is add soap in? Add soap in is a parameters. Now, what is the parameters? Here it is. It is two elements. Both those elements has to be integer. Don't, I mean, just get the idea, like, right? So this is a rule. I mean, we are defining a protocol that this is how two parties would communicate. So what I'm doing now here is, so SOAP UI is a testing tool. So if you give it a visual, right, it will generate all the requests for you. You don't need to write things. Okay, so I'm using this tool. I'm giving it the visual URL. So let's do it. What it is going to do is it will look up the document and it will create it will create the request. Now, if you look at the left hand side, right, it has created two endpoints and it is telling me there are four operations. For example, add. So if I open the request, okay, now this is how a request will look like, right? This is your, now guys, we are doing an API here, okay, but it is SOAP, XML based SOAP. Now here integer A and B. So let's give 4 and B as 5 and let's fire it. Now if you see in the right hand side, I'm sorry, where did it go? Yeah. So it gave you a result. That result is 9, right? So I hope you understood the concept, how the web services or the SOAP API works. So now what happens? Let us assume that this endpoint that I'm hitting, right, it is written in .NET. But I can write my code in Java, I can write my code in Python, PHP, anything that I like. Because I'm using HTTP, now I became language independent. So I hope with that you understand what is SOAP and what is HTTP and how web services actually work. Yes? Any questions? All right. I mean, the reason I'm always asking you is because since you are students, right? I don't know what part you might be. I mean, I'm not covering. There might be some terms that you might be hearing first time that I'm not aware of. So that's why. All right, I'll take it as yes. So that was SOAP. Now let's go to REST. Okay. Now before I explain the rest, right? There is one very common or one uh, what I can say a huge problem with SOAP. You might have observed it when we looked at this. You want to add 4 and 5, but if you look at this XML, right? So much information we are passing over the network, right? So when you fire these APIs over HTTP, if you have a performance sensitive environment, now imagine the amount of bandwidth you are utilizing, right? So people thought, why do I need to send so much XML when in reality I only need to send 4 and 5 and tell him that I want to do an ad? Why can't we have a uh, protocol which reduces this payload size, which reduces this network uses and the bandwidth? Okay, that was the reason. That was not one. I mean, that is one of the reason, but there are many reasons. But in order to make it simple for you, I'm explaining this. So that was one of the reason that REST came into picture. Okay. Now, SOAP, right? It is in use even today. There are many business critical live applications, not only in JPMC but worldwide. It is still in use because it is still a very much robust protocol. Okay. So let's go to REST. Now, REST, it stands for representational state transfer. Okay, it is very similar to SOAP. The difference here is that instead of XML, primarily we use JSON to pass the payload. Okay, now what is a JSON? JSON stands for JavaScript Object Naming. So it is something like a key value pair. Okay, maybe I can show you through a browser. Yeah, so this is how a JSON looks like. Where did it go? Just a minute. Yeah, here it is. If you look at this image, so if you want to pass some data, you will simply put it in curly brackets in a key value pair. So here, for example, it is saying document type 1, this is the number, this is the posting date, like and so. So you see the amount of, I mean, in XML, we have a start tag and tag, everything that is gone, right? You are only passing the bare minimum information. That is the reason JSON became popular. Along with that, another difference in REST is you use HTTP operation, okay, as a function type. Now, what do I mean by that? So here, right, if you look at this SOAP example I gave you, here we are querying it, right? It's kind of a query. Now, let's take an example of a student service. If you want to query service, so what it would be, you will pass a student ID and in response, you will get all the student data. Now that primarily is a GET request because you are doing a query. Now, if you want to add a student, right? So you will do a post. So in the rest, what we do, we rely on HTTP operations to specify what kind of operation you want to do. Whereas in SOAP, what do you see? That your operation is in the WSDL. You say that this is my operation, right? And you all basically in SOAP, it is always a post. Okay, but in the rest, what we do, we rely the HTTP operation. Now, if I go further, right? Uh, let's do one thing, right? I'll do a actual hands-on code, and we will all do that parallelly, right? And there we will see how the HTTP operation and how JSON is getting used. Okay. So now before I start with the actual code, right? This was all the theory that I wanted to cover. So if you have any questions, if anything you don't understand, I'll again wait for questions. All right.
Sir, I have one doubt.
Yeah.
Could you just explain the last point, CRUD through HTTP methods?
Yeah, we use this term. I mean, CRUD means create, read, update,
Yeah,
delete. We normally use when we simply write it as CRUD.
right.
So normally any APIs, right? All your operations can be divided into these four category. You will either do a create, you will either do a read, or you can update an existing data, or you might want to delete some existing data. Any API you take, student service, payment, anything you take, they all can be categorized into these four operations. And for these four operations, we use HTTP operations to specify what kind of operation it is. So if it is create, we use post. If it is read, we use get. If it is update, we use put. If it is delete, then we use delete operation. See, if you go online and look up, right, you will find more details. HTTP operations. It might be available on W3 schools.
Correct. Okay.
Uh, yeah, so these are the one. A lot of them are there, but for rest, we normally use this get, put, post, delete. Head is again for query, but yeah, this four is primarily used in REST APIs.
Okay, so yeah.
All right. Now, yeah, the next thing is I'll start coding, and I want to know how many of you are interested in parallelly coding with me. So I would like to hear that. Give me a thumbs up so that I get a rough idea how many are interested. If you're interested, I will do coding parallelly along with you. Otherwise, I'll simply go through the code and explain and give you a demo. If you have a laptop, we'll simply need one IntelliJ to write our code. Okay. All right. Okay. All right. It will become fast now. So, okay. So what I'm going to do is I'm going to write a REST service. Okay. In Java. Okay. Now the libraries that I'm going to use is Spring Boot. Okay. Now in order to do that, typically we do is there is something called as a Spring Starter. You can all go online and look up this page, Spring Starter. You can hit the first page. Okay. So what is this? So what Spring has done is it has created a starter page. So basically, when you write any code, right, using Spring, there is a lot of boilerplate code that never changes and always we have to write. So Spring has done a smart thing. They have given us an initializer. It is write a lot of code for you, and it will give you the classes, your dependencies, everything it will give you. Okay. So we are also going to use it. Okay. So first thing is project. Are you using Gradle or are you using Maven? Okay. I'm going to use a Maven. Now, what is Maven? Maven is a dependency management tool. It will all, but for simplicity, I'll say it is a dependency management tool. What I mean by dependency management tool, so when you write any code, right, you have So what I'm going to do is I'm going to search for web. Here it is Spring Web. I'll click on this and then I'll click on generate. So it is going to generate a zip file of all the boilerplate code that can be used. Okay. Now I have this zip file. I can extract it. Okay. Now what I can do is I can use IntelliJ and I can create a new project. New project from existing sources. So I'll go to my folder and open it. Now it is asking, is it a Maven? I'll say yes, Maven. Or create projects from existing. So let's use this one. Next, next. I think I'll used to need to use this model. Create new window. Okay, so this is how you open your project. Now I'll open the pom.xml. So Maven, right? All the Maven configurations, they go in this pom.xml. It's a XML document. It has all the dependency information. So if you see this, right, it has configured Spring Boot as 3.5.5 and we selected Spring Web, right? So it has added a dependency as this. Okay. Now if I do a sync, Maven sync, it is going to download this jar files, these libraries. If you see here, it has downloaded all those jar files. It has also downloaded a Tomcat because we need a server to run this, right? All these libraries it has downloaded. I hope so far you are with me. All right. So now we have a boilerplate code. Now we want to write a REST web service. So what I'm going to do is I'm going to write a service for let's say students. Okay. Now, in order to write it, right, what we need. So first we need to tell Spring that I need a REST-based API. So is through control. Okay. So what I'm going to do is I'm going to package controller, and in this I'll add a class. I'll call it as REST controller. Okay, but that is not enough. We have to tell Spring that this is a REST controller. So there is an annotation called as REST controller. Okay, next. We need four APIs, right? One is get. So what I'm going to do is I'll uh, to return, let's say students. Okay, student, all students. Be my API. How do I tell this is going to be an API? So there is something, I think it is get mapping or request mapping. Notation is there. Request mapping, yeah. Now in the mapping, I'll have to specify what is my path. Path is going to be what I'm going to do, I'm going to create a new package, let's say model, and I'll add a class student. Okay. String name, string city. Let's keep it 3. Now, because these are private fields, I will need some methods to access them, right? So generate get and setter. Okay. So now I have a student. Import the class list. Let's import the class. Okay. This is my controller. Now, what other method do I need? I need something for getting single student. Okay. So let's create that as well. Now this time, since this is going to be a single student, so I'll change this to slash student slash roll number. And here I'll have to say at the rate request param int roll number. Okay. So this is yeah. So we have created 2 APIs. Okay, let's implement first these two, then we can do the rest. Now, if you see right, I've created a controller package and a model package. Why have I done this? Because normally any web service or a or any web application, if you write, right, we follow a design pattern called as MVC. Keep this in mind. It stands for Model View Controller. So model is nothing but the information that you exchange. So in our case, it is student. Okay. Controller's job is to uh, control the flow, like from here where the flow should go. Its only job is to control, not to actually process. Okay. And view's job is to display. Now, since these are web services, there is no display. We don't have to generate any HTML. Okay. So that is about it. Now, the actual business logic we will put in the service classes. So I'll create a package called as service, and I'll going to add a new class called as, let's say, student service. Now I must tell Spring that it is a service. So how do I do that? There is an annotation called as service. Now don't worry about all the annotations that I'm using, right? Uh, just get an idea of it, like how it works. Okay. Eventually you will all learn this, but my purpose of explaining and going through this code is so that you understand how the industry works. We don't, I mean, for example, if you see I'm layering all my classes, right? That is how in an industry people code. They don't write everything in a single Java. They use dependencies, they use Maven, right? And Spring Boot, so many annotations are there. So it's okay if you don't understand it fully, but try to get the gist or the idea of it. Okay, now I have a student service. Now what does the student service needs to do? It needs to do two things for now. First thing is it needs to return all the students. List of student, get all students. Okay, this is my first API, first actual business logic. The next one is get student. Now here I get a roll number. Okay. Now Ideally you would have a database, but here to make it easy, right, I am not going to use a database. I am going to create a static list. Okay, public static list of students equal to new array list. I'll copy some code here. Just a minute. Okay, so it is in my previous demo. I moved it to a different class. So let's do that here also. So there's something called as utils. So what I'm going to do is I'll create one more package to store all the utilities. Let me copy this also. Okay, so now it is giving an error that there is no constructor. So I'll do create constructor. So it has added the constructor. Okay, string name, city, and this is your roll number. This dot roll number equal to roll number. All right. So as you can see, right, what I have done instead of using a database, I am using in-memory objects to make it simple. Okay. What is the problem? I have to import it. Okay. When we do get all students, what I will do? Very simple. I will return students. Okay. Now, when I have to get some only one student, what I'm going to do is I'll have to iterate through this list. So what I'm going to do is for student s in students, if s dot roll number is equal to roll number, I will say return s. But if it has not returned, then what will happen? So that means student has not found. So what I'm going to say, I will throw an exception, throw runtime exception, student not found. Okay. Now I have written my implementation. How do I use it? So I'll go to the controller and I'll create a service. I'll invoke the service. So I'll say private student service. And here I'll say return service that get all students. Okay, and here I'll say return service dot get student with the roll number. Okay, it is complaining why. Okay, return type is incorrect. The return type has to be student. All right. So now we have prepared two APIs. What I'm going to do is I'm going to run my code. How do I run it? I run this application class. Now let's see how it runs. Okay, so Spring Boot has started. Okay, it has started on port 8080. All right. So what I can do is I can use browser localhost colon 8080. Perfect. You see this? There is a 404. So the service is giving me 404. That means page not found. So something is wrong in my request. So what I'm going to do is slash students. So you see this? It is showing me two students. Now I only want first student with roll number 1. So I'll say student slash 1. 400. Something has failed. Very good. What has failed? It is not able to map it. Perfect. So I wrote a code that is not correct. So I think instead of request param, the annotation is something else. So I'm going to refer my old code. Oh, this is how it is done. Path variable is to be used. All right. Okay, I've changed my code. Let me stop it and start it again. Okay, let me run it again. Yeah, it is only showing me student with roll number 1, student 2. Perfect. Now let's fire something which doesn't exist. See, it is giving me 500. What does that mean? Something is wrong in the service side. What is wrong in the service side? There is an exception that we see here. Student not found. But ideally, this exception should be thrown back to the customer. Okay. All right. So now we have implemented two APIs. I hope you see the beauty of it. Do we all now understand what are REST APIs? Okay, I'll treat that as yes. All right. I mean, in the similar fashion, right, you can write more APIs. For example, you want to add a student. So what you will say, let's say public void add student, right? Now, when you add a student, you will need to get the student. Now, what annotations you will use? Something like request mapping. Now, when you add a student, your path will be slash student only. That's it. But your method this time will be request.post. Request method dot post. Okay, this is how we will do it. Not required here. What is it? Yeah. So this is how you write. Now, when you write post, right, you cannot use browser actually. So this is where you need something called as a postman. Let me see if I have one. Yeah, here it is, postman. Yeah, you can use postman to to fire APIs. So this is also one of the testing tool. If you look at this, right? What you have to do here, you have to select your method as post. In body, you will pass student like this in the JSON. When you send this, it will accept your object. All right, I think you have understood the gist of it. Okay, I'll move on with my slides. So that was how you implement REST APIs. Okay, we have built this REST service. Now what is next? So, so this session, right? This was an attempt for college students to get the idea of how the REST APIs are used, what are REST APIs, and a bit of how industry operates, right? But this is not enough. Obviously, you are probably in third year only now. But what I would recommend is if you are really interested, you can learn some of these items that I've listed here. If you are interested in Java, you can go for Spring Boot. If you are want to go in Python, you can learn what is Django. So these are all web services framework, basically web frameworks. Okay. The next thing is API security. I mean, the code that I wrote, right, we have not implemented any security. But in the real world, right, we need APIs to be secured. Let's say you have 4 APIs, get student, but you will want to restrict your add student only to your college admins. Only your office should be able to add students, whereas everyone else can query student, right? So you need to have security. You need to create roles that my office should be able to do so and so APIs, but rest of the people should be able to do only so, right? So that is about API security. Next is Open API specification, which was also known as Swagger. Now, if you remember in SOAP, right, we had a XML document called as WSDL. Similarly, in in the REST APIs world, right, when you have a service and you want to pass on the information to your clients or someone else, right, we use something called as Open API, Swagger document. Okay, I have not covered it here to make it simple, but you can learn more about it. Okay, so that was about frameworks. The next three items that I mentioned here are related to the design patterns actually. One is dependency management that I have briefly covered when I explained Maven. The next thing is dependency injection. Now, regardless of what language you choose to use, be it Java, Python, .NET, anything, right? Go, Ruby, anything, you must understand what is dependency injection because that is really the core of how the object lifecycle is maintained, right? I mean, in reality, we don't prefer using constructors to create object. If you've seen the code that I've written, nowhere I've used constructor to create my service class or controller class or to create student class. I mean, I've not created any single object. Why? Because I have used Spring. And what Spring does, it uses dependency injection to manage the object lifecycle. And that is how the industry normally operates. So this is really crucial. You must put an effort to understand what it is. It will definitely help you in your initial years in the industry. The next one is continuous integration. The code that we have written, right? It needs to be built. It needs to be tested in an automated fashion. It needs to be deployed in an automated fashion, right? So that is called as continuous integration and continuous deployment. Now that is achieved through something called as Jenkins. Okay, you can Google it out and try to learn it. Okay. The next one is GraphQL. This is an advanced topic. This is in use. Not everyone uses it, but some industries and projects use it wherever it is applicable. So what is GraphQL is some simple concept. So let's say you have a service which is talking to, let's say, 10 different services. Okay. Let's say you are calling get student, then there is some other service you are calling, let's say get book details. Now it is giving you a JSON which has a lot of information, but you only need few information. From student, you only need student name and roll number. You don't need his address, you don't need which class he is in, you don't need which city he is in. And from book, you only need book name or you only need book author. But rest of the information you don't need. So when you fire 10 APIs, there are so much payload getting exchanged over the network. So what GraphQL does is it lets you query over on top of APIs. You get it? So you can specify that from this student API, I only want to get the ID and name. From this book API, only want to look at the author. So you only get a minimal payload, only the information that you need. It's like a advanced version of REST wherein you kind of query over the APIs. So that is GraphQL. It is heavily used in Twitter. Uh, yeah, so that is all I had. Yep. Any questions or anything you have to ask me? Not just related to REST APIs, but anything related to industry or any technology. If you have any question, you can ask it here. All right. Rohit, you want to take over? Let's wait a couple of minutes, guys. Don't drop.
Yeah, yeah. So we'll be showing the feedback form and the like photo consent form. Yeah, so like we want to wait for the questions or are we done?
We are done, Sakshi.
Okay. Okay, I'll share my screen. So I request everyone to please scan this QR and like share your feedback. We'll wait for like 1-2 minutes for this. Are you all done or like people are still filling the forms? If not, then let me know. Otherwise, I'll move to the next. Okay. So scan this QR as well. This is for photo consent. And like please fill the details as mentioned here. Like event name is C2C REST API. Date of the event is this. And if you're a JPMC employee, no. And yeah, fill it like this.
Sakshi, do we also need, I mean, do I need to do this?
Yeah, yeah.
Okay.
So this is so Lalit, this is for the photo that we will take right now. we will circulate that internally within the firm, right? Or within for emails and everything. So we need consent.
All right, yeah.
We've not done this in the past, I know, but this is something that's new. I mean, updated process now.
Yeah.
Give it another two
Yeah.
minutes.
I think people should be done by this time, correct?
Yeah.
Yeah, I'll start.
Okay. And Sakshi, maybe you want to take a quick picture. I would request whoever can, it's
Yeah,
not a mandate, whoever can switch on their cameras, it will be great to
yeah.
click a nice picture. Good to see a few faces now.
Yeah.
Now I know. I mean, there were people behind.
No, I think they're all sitting as an entire batch, I believe,
Yeah.
Yeah.
the students, right?
Yeah. Some of them do have machines as well.
Yeah, laptop. That's good.
Okay. I'm clicking a picture now.
Sakshi, your camera is off, by the way.
Yeah. Okay, one moment.
Oh, someone started screen sharing.
Oh, someone started. Can you please stop whoever has started screen share? Rohit, do you have access?
I am. I do not.
Okay.
Okay.
Yeah. One second, I'll move to the next one as well.
That's fine. Even if we get one good picture, that's okay.
Yeah, we have.
Thank you,
Yes.
everyone. And
Thank you all.
do reach out to us if you have any questions. Thank you.